Okay, so we're starting to look at MVPN next generation, and there are a few things I just wanted to highlight as we go into it. So in essence, IGMP comes in on the customer side. We're going to be running customer PIM from the CE to the PE, and that's the good old-fashioned PIM we're really used to, just with the prefix C to make it customer PIM. We're then going to be converting that into BGP signaling messages. Then on the other side, we're going to be dropping back into customer PIM, and then that's going to be responding to the IGMP in the way that we're used to. So the customer PIM really is no change from basic PIM. We're just calling it customer PIM now. Now we could be running provider PIM in the backbone, but we're not going to. We're going to run BGP signaling because provider PIM in the backbone, although it works, it's not as good as the BGP signaling. So that's what we're going to do. Now, as we do those conversions, things might appear a little bit complicated. So we're going to be going through all of that detail in the next couple of slides, but a few things I just wanted to highlight. So the first thing, when we turn on multicast VPN inside our routing instance, so we're going to be in the hub and spoke, in fact, this pink hub and spoke. When we turn it on, whether it's hub and spoke or not, so we're in the routing instance, we turn on protocol MVPN. This is going to affect the unicast routes. So you turn on the multicast signaling and you enable multicast, and yet the unicast routes get changed. And what happens is 2 new communities get added to the unicast routes. Now, the first community is a source AS, which is added to the unicast routes, and this is designed to aid in inter-AS work on the multicast. We're not going to go into that. However, the other one is something called an RT import, and this is basically an extra target. So we turn on the multicast MVPN, and the unicast routes pick up this extra target. And the reason is this is PE specific. So you can see here that this is the PE IP address itself, followed by a number that's generated automatically by the Juniper router. It's related to the process ID of the VRF interface. So why has it done that? And the answer is that the multicast really needs to know where these routes are coming from because of the RPF checks. So to prevent duplicate paths, we have the RPF checks exactly the same as we do in ordinary multicast, and we really need to know where that route is coming from. And so the PE that's advertising the unicast route on the path to the multicast source gets this extra RT import. And you can see that in the standard route tables just by looking. So that's the first surprise, the fact that we're turning on multicast and the unicast routes get affected. And you can see the extra communities here. There's a couple of different ways to see them. This is one of them. You can actually type show policy. I apologize. Show policy, and it will show you the invisible policies that are added to create these extra communities. Okay, the next really big surprise, in my opinion, on this is how automatic the process is. So we're going to need a multicast data path through this cloud, and that's going to be, a point to multipoint LSP. Now, obviously, a point to multipoint LSP could really be quite complicated to set up, and it does it for us. So inside the routing instance, we type set provider tunnel. We want to use RSVPTE in this case. We put in a label switch path template, which is a really very simple template, or if we're using a default template, then that's it. And so the actual data path creation of our LSPs is incredibly easy to do with this Juniper system. So that for me is a real bonus there and a real surprise. So 2 big surprises, completely unrelated. One is how easy the P2MPs are, and the second is the fact that you turn on the multicast and the unicast gets affected.